Hi, Intermediate Algebra students. Happy Thursday. This is Miss Leminski. I am glad you found this recap video for 4.2a. As a reminder, you should have already watched the lesson last night. You're going to watch this video, and then you are going to jump right into your 4.2a Pearson practice. Okay, so last night you learned how to solve a system using substitution. This was just a quick warm-up where you were given a system of equations, and we were going to look at the first step, which is again to isolate a variable. So we get the y by itself by subtracting 2x, and we end up with y equals negative 2x plus 3. Now it says Laura solved a system of equations using substitution, but she made a mistake. What was it? In step 2, you'll notice that Laura then took that same equation and plugged it in for y. You cannot do that. Instead, she should have taken the second equation for step 2 and substituted the negative 2x plus 3 for the y in that one. All right, so let's move on and do some examples so that you have good practice before you jump into your Pearson practice. So here's our system. I want you to write this in your notes. So get this down real quick. Negative 7x minus 2y equals negative 13, and x equals 2y plus 11. In the first couple of examples, we're going to walk through a step-by-step flow chart so that you can continue to think about the steps you need to go through. So Ms. Krupstad made this, and I thought it was a clever way to talk about it. But you do have to have that system. Okay, so here we go. So in this one, you can see that it's the same system. Okay, step 1, look at the equations. But then we're going to ask ourselves, is there a variable isolated? Meaning, is there one by itself? And as I look at that, I see that in the second equation, the x is all by itself. That means it's isolated, so yes. So in this flowchart, I'm going to go here and down, which means now step 2 is to substitute the expression for the isolated variable into the other equation. Solve for the leftover variable. So I'm going to take that same system, and again, you should have written it down. We had negative 7x minus 2y equals negative 13. And x equals 2y plus 11. And what we're going to do is we are going to take the 2y plus 11 and substitute it in for this x. So that's going to go there. So I go negative 7 times 2y plus 11 minus 2y equals negative 13. Also in this step, I solve for the leftover variable. This is why you did the lesson that you did on Wednesday or yesterday in class, so that you could practice solving for variables in these situations. If there's parentheses, we need to distribute. Negative 14y, negative 7 times 11 is minus 77. This is not inside parentheses, so I just bring it down, equals negative 13. Next, we need to combine like terms. Negative 14y minus 2y is negative 16y. Again, just bring down that negative 77. Okay, so we get all the y's together. Now we get this negative 16y by itself by moving the negative 77 to the other side. Negative 16y equals negative 13 plus 77 was 64. And finally divide by negative 16. So you can see, which gave me negative 4. You can see that being able to solve an algebraic expression like this, like you did yesterday in the Pearson practice, is critical for being able to solve by substitution. So if you struggled with that, make sure you get to office hours at some point or keep practicing because you have to be able to do that algebra. That was a previous skill. Okay, so now that we've done that, we're going to go down and we're going to head to step 3. So we know y equals 4. So we have y equals 4. So now we're going to take that and substitute it into one of the equations. Well, I'm going to use that second equation, which is x equals 2y plus 11. Or what that means is I'm going to plug 4 in for the y. X equals 2 times 4 plus 11. Nope, that's not true. It was a negative 4. That's why. Sorry, I go back to the previous slide. It was a negative 4. I forgot to write down the negative. Y equals negative 4. So x equals negative 8 plus 11. I get x equals 3. Remember, my answer is always going to be an ordered pair. The x has to go first. So even though I found it second, that's the first number in the ordered pair. 3, negative 4 is what I believe my answer is. But remember, step 4, your final step is to always check. As Ms. Bradagam showed you in the video, you need to check it in both equations. So as a reminder, my first equation was negative 7x minus 2y equals negative 13. The second equation was x equals 2y plus 11. All right, in this example, I would plug in the 3 and 4, so negative 7 times 3 minus 2 times negative 4 equals negative 13. Negative 21 plus 8 does in fact equal negative 13. So that one works out. And then in this one, I would get 3 equals 2 times negative 4 plus 11. 3 equals negative 8 plus 11, which does in fact work out as well. So my solution is 3, negative 4. Okay, let's do another one. So once again, I'm going to actually go to the next slide. So here's my system. Step 1, look at it. And in this case, when I ask myself if a variable is by itself, it is not. So I need to go to the right. So if there's not a variable by itself, then my first step is in fact to isolate a variable. So in the next slide, I'm going to choose to take one of these equations and get a variable by itself. When I look at them, I am going to take the top equation and do that because I see that the y is a positive 1y. And that's the easiest thing to solve for. So I need to isolate that variable. Again, I'm taking that equation I just showed, which was 2x plus y equals 20, because it's one step to get the y by itself. All I have to do is subtract 2x. So I get y equals negative 2x plus 20. That's all I have to do, and now I get to go over here to step 2, which we did before. Now, since I simplified the first variable, this was the mistake that Laura made in the warm-up. I need to now take the second equation, which was 6x minus 5y equals 12. And I'm going to substitute this for the y in that equation. So I get 6x minus 5 times negative 2x plus 20, and it should in fact equal 12. When I go to do this work, I get 6x plus 10x minus 100 equals 12. Combine like terms, I get 16x minus 100 equals 12. Add 100 both sides, and I get 16x equals 112. Divide by 16, and x in that case would equal 7. For the next step, I remember that x is positive 7. I go down to step 3. So I said x was 7. In step 3, I take one of my equations. Now I'm going to go back to that first one. I took my simplified form. So remember we started with 2x plus y equals 20, and I simplified it to y equals negative 2x plus 20. I could use either one. I chose to use this one because it's already solved for y. Negative 2 times 7 plus 20, negative 14 plus 20. I get that y equals 6. Okay, so I get that x is 7, y is 6. The x goes first, so that's 7. Y is 6. That will be my answer. Don't forget, you should, in theory, check the answer in your two equations. I'm going to skip that part for now, simply for the sake of time. Okay, so you plug them in and you would, in fact, see that they're the same. All right, I want to do one last example without using these charts because I do think that looked a little confusing at times, because usually you just do it straight through. Okay, remember though, step 1 was to isolate a variable. They're not isolated in this example, so I'm going to take the first equation, 3x plus y equals 5, isolate the y. So I get y equals negative 3x plus 5. Once I've done that, I take my second equation, or the other equation. I'm going to substitute this in for the y. So I have x minus 2 times negative 3x plus 5 equals negative 10. Now I only have x's left, so I solve for them. I get x plus 6x minus 10 equals negative 10. Combine like terms, 7x minus 10 equals negative 10. Add 10 to both sides. And I get 7x equals 0 by 7. X equals 0. Once I have that, I plug it back into one of my equations. Again, I can take the simplified form if I want. So I'm going to take y equals negative 3x plus 5. You would also be able to use the top. Y equals negative 3 times 0 plus 5. Y equals 0 plus 5. So y equals 5, which makes me believe my answer is 0, that's the x, comma, 5. Last but not least, I will do a quick check. My first equation was 3x plus y equals 5. Plug in 0 for x, 5 for y. Anything times 0 is 0. Oh, I do, in fact, get 5 equals 5. Second equation, I had x minus 2y equals negative 10. 0 minus 2 times 5 equals negative 10. I get negative 10 equals negative 10. So it does work. Okay, I told you I'd keep it to 10 minutes. I'm at 10 and a half, so sorry I went a little bit over, but those are 3 examples of what you need to do. Now, your Pearson assignment for section 4.2a is up, and that is also only 3 questions. So please make sure you have paper and pencil out, write out your work, and then type in your answers. Good luck, and remember, no matter where you're at when the bell rings today, I need you to submit that Pearson practice because that is your attendance for today. Thanks.